Hello Abhishek. Hi, I'm so pleased to meet you.
Either data science or computer science or statistics, operational research as well. All of those are sort of good candidates for data scientists. A lot of the job roles, as you said, particularly for data scientists, the job roles seem to be all over
the place. Absolutely. Understand yourself. You only because you can play with a lot of data does not mean that you can become a data scientist or an ML engineer. You may as well be into data mining or something like that, or data analysis for that matter.
An ML engineer is really a software engineer.
So me and Abhishek were colleagues at Amazon. He is a seasoned applied scientist. I've not seen anybody as like him. He has been a pivotal person in the Amazon's international machine learning research. More than 1,000 models, generating over $500 million of revenue. His background is in software engineering, right?
Yes.
Right.
Yes.
And you've done your master's from the UT Austin.
Yeah.
Wonderful, wonderful. But the most important thing is his contribution into some groundbreaking projects for Amazon, where he had this chat experience powered by the retrieval augmented large language models, the LLM1, right? Yeah. So many other projects. We also together delivered some of the browse node classification, complicated term, but we did.
Yes.
But we did, and it made a huge difference. So girls and boys today, we know that there is a lot of demand on ML scientists, AI engineers. Actually, they all mean the same together. But today we are going to explore what each of that means. What does it take to embark on the journey of being an applied scientist in this world? What kind of background one should have, and what kind of right people are suited for that role. So yes, you did tell me one very important thing, that people usually ask you, what is the difference in roles between data scientist versus applied scientist versus research scientist versus data analyst versus business intelligence analyst. My God, so many. I'm having to refer my phone for that one. But there's more. There's ML engineer, there's ML ops engineer, and so forth. So yeah, I mean, today we, at any given point in time on LinkedIn India, we see more than 100,000 jobs that range across these different titles that I just mentioned. So let's start with debunking as to what they are, and is one person suited for the other, and so forth. But what do you need basic to start with?
Got it. No, thanks firstly, Ruchita, for having me here. It's really a pleasure to be here. And yeah, I this is a topic obviously very close to my heart. I love talking about it. I've spoken to many people about this. So the role difference, I mean, obviously, as you said, there's so many different roles. It's really very confusing, and it's very interesting because this ecosystem has really grown in the last 5 or 10 years from maybe like there'd be only small teams in companies, but now as more and more companies are recognizing the ability for machine learning and AI to be really transformative. I mean, you spoke about how we worked on a project, right? So even smaller companies, especially in the last year, with ChatGPT becoming such a large phenomenon, a lot of companies are realizing that they do need ML teams and scientists and folks with various levels of expertise. And so it's grown from a fairly small and very niche role to a wide spectrum of roles. And it's a really great question. I think a great place to start, where we talk about what is the difference between the different roles, right? And how I like to think about it is there's only 3 main roles in machine learning, and the other ones are, let's say, like subsets of the role. So the main 3 roles are a machine learning engineer, a data scientist, and a research scientist. And my own role, which is an applied scientist, is somewhere between a data scientist and a research scientist.
Okay.
Other roles like software engineer are a little bit to the side, but they're much more on the, like, similar to a machine learning engineer. And those like business intelligence engineer are also sort of subsumed in a machine learning engineer. I'll say that any machine learning engineer typically has enough just raw tech skills to be able to do the job of a business intelligence engineer, maybe not the other way. So and depending on the team, maybe they have to pick up a lot of let me abbreviate it, BIE roles, sorry, BIE tasks. And very similar to that, in a data scientist, we have a very similar relationship to a business analyst, where a data scientist can typically do more or less everything a business analyst does. But I mean, they are important roles in their own respect,
Yeah.
right? An ML ops engineer is again something that is subsumed by an ML engineer. Okay, so with this like really high level,
the ecosystem of it.
Yeah, let me kind of talk about the three core roles, how they differ from each other. So an ML engineer is really a software engineer, but the idea is that they own ML services.
Okay.
So, like think about Google search. Like Google search is a very complicated, big system. You know, or even Amazon search. Any search engine has many steps to it, right? One part of it is, of course, the modeling required to go from given a user query up to the different results. That's one side of it. But even like if you think about Google, they index almost the entire internet. You know, it's a huge problem just at a technical level. Like imagine like hundreds, maybe millions of terabytes of data to just ingest that and systems to store that and retrieve it at such fast pace. You need very core and very hard technical chops to be able to do that.
Yeah.
Right. So an ML engineer's job is all about building those kind of systems. You know, if I had to give like a list of sort of tools they use day to day, it would be Docker, maybe scikit-learn, Hugging Face. These are just like libraries and things that they do, interact with day to day. But the main point is related to the fact that they are at the end of the day engineers. You know, they own the health of the service. They own whether the service is up or not. They solve the challenge of taking a model like the one which I had built and we had worked on and actually like making it usable for people, connecting it between users and the backend system.
The backend system.
Building that bridge is really what the ML engineers are really doing.
That's a very interesting point here because people usually. What has happened today is that when I was looking at certain job postings on ML engineers or data scientists, the job descriptions name the same, even for a property management company.
Right.
Like everybody wants to venture into. If you're not doing something AI, if you're not doing something ML, then we are yet not, on the pedestal to be, something at the forefront in our industry as such.
Right.
But this whole thing, whether your even industry needs it, right? Whether you need to bridge this gap of whether the models that you're creating to the users who would actually need it.
Yes.
Does your user even need it? That's why do you need a model? Do you need a bridge between the two? That's yet not, comprehensively well understood in many places as such. Yeah.
Very well said, like I always like to say that in a case where you can use a rule, an if-else statement, a simple for loop to do the job of an ML model, don't use ML. Simply because an ML model can fail. There's always failure cases, and whenever I work with business teams, I always educate them that what you have before the project even starts, before the model is launched. I always educate them that you have to tell me what will happen if this doesn't work, because the times it doesn't work might be small, but they will always happen.
Yeah.
And it's very hard to know what exactly is the model going to do. Sometimes it gives very strange results. So planning for that failure is really a very core part of ML engineering, data science, everything. Right? Yeah,
and this whole thing about predictive analytics is about a prediction, right? End of the day. The whole, the latest project that I worked on, even that 5% accuracy gap can actually lead to a very large percentage of customer kind of, contacting you and increasing your OPEX generally. Wow. No, okay. This is very, very nice. So I'd like to kind of understand more from you in terms of, when I know you are mentoring a lot of junior engineers, right? Who do you see? Like one point you said that you should be ready to fail.
Right.
Do you see that, junior engineers who embark on this journey with you to learn more as being ML engineers or so forth? What do you see what is the traits between those who take up that as their career forward, and many may be falling out as well, I'm sure about it. So what can you see as a clear difference in their mindset or their thought process or their analytical understanding?
I'll just clarify this a bit by saying that I mostly work with data scientists, ML scientist style folks, right? I do a lot of work with ML engineers as well. And this is actually what I wanted to kind of bring about, but you raised the question at the right time. Because in ML engineering, it's a separate job ladder. Like I said, it's very close to software engineering. So a lot of the typical aspects of a software engineer are the points of success, right? Like being able to estimate tasks well, being able to take a complex system and break it down into its component pieces, attach those pieces, designing, software design, all of those things do actually play a part over here, even for an ML engineer. I'll say the real difference is the understanding of how they approach failure, like what we just talked about.
Yeah.
Like because the system is something where failure is not an edge case but a very average case. So building the system to be resilient, building the user experience such that failure, has it's like a soft failure.
Right.
And particularly in identifying places where failure is acceptable is also, I would say, like at a higher level, a really good skill for like principal ML engineers. Like just kind of see, it's possible to build a model in almost all cases, but would you build a model for like predicting like your disease versus predicting your search results, right? I mean, in the search results, it's much, the cost of failure is much lower. And it's also possible to, but the upside is really good, right? If you can get really good search results or product recommendations, all of those things are, they have a great positive impact for the user.
Absolutely.
And getting it wrong has a low negative impact. You can just ignore the recommendations. So identifying these sort of scenarios is what a good product manager does, or even a principal like ML engineer will kind of do.
Right.
Kind of telling product that this is a good place to apply it, this is not a good place to apply it. Something I think it's really great for them to do.
Right. So an application, understanding of the end application.
Yes.
And
exactly.
the implication of the inaccuracies is something that the ML engineer should have a foresight for already. Right. Oh wow, that's nice.
So in this role, for people who are more junior, who do want to grow in this role, I would say that the typical software engineering skill set is good. Like you should be able to debug issues and go very deep at the technical level of what is happening, why is it happening, some sort of future planning, and kind of being able to give estimates. Like software engineers are very bad at giving estimates. I haven't been a software engineer.
The t-shirt sizing.
T-shirt sizing. And it gets even worse with ML projects because there's this other side of failure. But over time, you do kind of get a hang of it. So I would say that that's a fairly well-known skill set, and it's just kind of deeper than that. An ML engineer, by and large, tends to have deeper technical chops, I would say, than an average software engineer, because over here the technology itself is still fledgling, is not fully like straightforward yet. There's a lot of actual figuring out. It's a very complex system. At the systemic level, it's quite complex, and so figuring out all those things, I feel, does require a higher level of technical expertise compared to like an average software engineer.
Right. So a software engineer who is already a software engineer has some experience in kind of the logic and building a code or something of that sort. They are better equipped to take up a role as an ML engineer because of the core fundamental understandings that they have right now. But by then they've also actually seen user behaviors and they've seen application understanding. Right. So anybody who is just completed their engineering graduation should more look at doing their software engineering for a couple of years before they can kind of embark or launch themselves into ML engineering. But coming back to the launch, like, does ML engineering, not all companies are like Amazon, and even in Amazon we have seen that not everybody gets an opportunity to be working on a project which is based on ML or with an ML engineer or so forth. In that case, what should one do after 2-3 years of experience to kind of make sure that they have some ML experience on their resume if they are interested into going forward?
Right. So I definitely feel like it's a matter of orienting your profile towards the sort of technologies which are very widely used. Like every single software engineering, ML engineering manager, they're looking for someone who can hit the ground running. They want someone who, does not need to upskill both on the technical side and the ML side. So there's a very basic core understanding of how ML systems behave, how ML models behave, which I think is quite core for even an ML engineering job. And typically, when they do interviews, they have at least one round, which is like just fundamentals of ML. The way the applications are developed, the way the user interaction happens, all of that it's hard to learn it on the fly necessarily.
Interesting.
As in, you can, but it takes a longer time. And when things are moving fast, you want someone who already knows it, right?
So that's a very interesting point, because what you're saying is that, basic understanding of ML is usually expected out of an individual.
Yes.
But how do they get that? Because even I have taken up some courses on ML. We have the ML University in Amazon as such, mainly for the leaders and so forth. But it just gives you some theoretical understanding, a couple of practical but not very practical algorithms that they help you with. So how does one, again, how do you move that into a much more practical experience to show that you have done something around it, something which your work may not provide an opportunity, but you have done it outside of work.
Got it. No, so I think the best way and possibly the most fun way to do it is to actually just pick up an application which you think is really interesting and build something out of that. This is a very typical software engineering way approach to projects, right? That you'll start with a application which you just think is interesting. Maybe you want to let's say this video, you want to just podcast, or you want a way to kind of make notes in a really seamless way where you can dictate, plus you can write, plus you can get well formulated notes. So that sort of tying together, it would have to tie together many different pieces. You maybe have a ChatGPT component to it, maybe have a component to this model called Whisper, which does the transcription automatically.
Right.
So tying those together and tying it towards maybe some measurement of how good it is, right? Which could be user interactions if you host it, or if you take a slightly different problem, it can be an accuracy metric. Building something which touches a real world problem is a good way to just get a sense of how to, and particularly hosting it for other people to use behind a website or something, small website. That's a good way to really build something and then sort of understand the UX perspective of it, or see how people use it, right? And that helps inform you on what should you do the next time, on how to build it better, right? Like the problems, for example, if you build a website and you're doing this transcription thing, but you see it's super slow. Somebody says something and then 10 seconds later the text comes
in.
Then you would kind of feel, okay, this is not a good experience. Now I need to change something, but what do I change? Your mind starts going to that sort of question, and then you explore a little bit more on, okay, the model is so big, maybe I can use a smaller model. Maybe I can do quantization. There's a variety of tricks which you explore. So, but it's all backwards from sort of making the user experience really good, making a nice product at the end of the day. Right. So I feel that's a really great way to guide your projects. It's be this is something which I would use, and have a very high bar for yourself.
Got it. Understood. But the question again arises, I'm just putting myself in the shoes of a young engineer and say, great, I know that farming today needs a lot of predictability, considering the weather conditions, and there are a lot of models that provide weather related information and so forth. How? What is my next step? Is there free resources available outside today for me to build a project and learn or top it up on top of it?
Absolutely.
How would you go about it if you were to kind of start from there?
So if I were to, something particularly about agriculture.
Let's say an example, right? An example that I'm very close to, because that is one region where I feel that, it's not run by a very educated group of people. They've observed things over the years, but they are all subject to change. Like a farmer's life that depends on the environment, the weather, the quality of the soil, they're all subject to change over a period of years. But they are not a very educated bunch of folks as such, right? They cannot hire an AI software or something. So I'd like to build something for them. That's what is in my head, right? So how would I go about it?
Got it. So the first step, what I would typically try and see is what have other people done. Right, because, and this is really where one particular website called Kaggle is really great.
Okay.
I think a lot of...
Sorry, what is it?
It's called Kaggle.
Kaggle, okay.
Kaggle. So Kaggle is a website, I think it's owned by Google now, but basically they host a lot of challenges, which are completely ML and data related challenges.
Oh wow, okay.
So it's a lot like, Code Forces, Geek for Geeks, Hacker Rank. There's a separate, just in the software engineering domain, there's a lot of these sort of coding competitions. So it's really similar, but for ML.
For ML, right?
Yeah.
And you find your similar community there as well.
Exactly.
Okay, brilliant. Because that's where when you're building something, and the chances of failure are high, you need somebody to validate with and learn or understand or something. Maybe inspire yourself.
Exactly. Right? And that community has a lot of practical tips on how to make things work. I think that community is the most adventurous in trying. Like just new ideas, like we'll use ChatGPT to generate the data set. Like these sort of crazy ideas is something which the Kaggle community I think really starts with.
Right.
And for particular problems, I mean, they focus it around like a particular problem, which is a little bit of a made-up problem. I mean, it's not necessarily the most real problem, but the solutions they come up are often really innovative. So if I wanted to build something in the real world, I would actually use that because these are very practical solutions. The insights they get about the data, the kind of model interactions with the data, really invaluable in my opinion.
Perfect. No, that's exactly what people need, those who don't have access to a lot of free training courses or so forth. Like there are courses, but they are expensive. Not everyone has it. But we do know that engineering institutes are spread across India. But the quality of engineers that we are getting out of it, the curriculum nowhere includes what is needed to climb the corporate ladder.
No,
but they have to bridge this gap, and that's where these kind of tools, these kind of initiatives are super important. So ML engineering we covered. Let's talk a little bit more about data scientist. How does it differ from ML engineering? Why is there so much of thing about, I mean, I know why it is about a lot of data mining and so forth, but how does data and ML are very close to each other. Without data, ML does not work. So what are data scientists, data engineers?
I spoke a little bit about what is an ML engineer, right? The job is, like I said, software engineer who owns systems which deliver ML solutions. Systems which need to have some component of potential failure, but still very often provide a big upside. But at the end of the day, they don't own the models which are behind the scenes, right? I mean, like for example, suppose Google search has a precision of like 50%, right? Versus being 60%. The ML engineer is not concerned about that. The model behind the scenes is probably the same. But a data scientist who works on Google search is the person who owns the performance of the model. That's how they are measured. Their own job is kind of measured by how good the models are. Can they improve the models and the various metrics? So it's a very metrics heavy job, and they work very closely with business teams. I would say like in the project we worked on, I was taking the role of a data scientist more than anything else.
Okay.
Where we are, I was very focused on, we are improving it by so much, we are trying these different techniques. And I think like because of this, right, because of the sort of difference in ownership and the difference in who they are sort of beholden to, they're kind of reporting their numbers to senior leadership or other folks who will take like their work and kind of convert it into something which many people can use, right? They can take like something on let's say my laptop and then convert it into something like a lot of millions of users can use. Right? That bridge, like I said, is the ML engineer. But the data scientist does need to obviously come up with the core ML model, right? Now, this requires a very different skill set. There's some overlap of skill set, but it requires some skill sets which may be quite surprising. Like one of the most interesting skill set is just being able to look at the data. And a very undervalued skill set. Look at the data, ask a lot of questions about the data. Frankly, grab it in an Excel file and like stare at it and I mean, run different analysis, like very basic analysis on it. Just to kind of tell you what is the data telling you, extract what you can from the data, right? That's like what you have to do before you even get to the whole modeling side, right? And on the modeling side, because that's a very mathematical field, typically, they do look for people with a master's in either data science or computer science or statistics, operational research as well. All of those are sort of good candidates for data scientists because they do need to understand the model at some level of depth,
right?
And they do need to understand the difference in the modeling techniques. Like for example, if you're building a deep learning model versus an XGBoost model, right? What is the actual core difference between that and ML engineer maybe won't care. ML engineer will care, okay, one is like 50 milliseconds latency, one is like 10 milliseconds
Understood
latency.
now. Yeah.
But the exact, ML difference is what is the different learning which is happening inside the model against the data for this particular kind of data, which model is the most suitable. That's something a data scientist really has to be, that's what they're experts in. That's why they are paid, frankly.
This is something that I have also learned today, actually, that, the data scientists are actually the ones who are curating the ML models. Is that right? Am I saying that correctly?
Yes.
But the performance of the ML model is more of an ownership of ML engineer, such.
The performance, as in the engineering performance.
The engineering performance, absolutely.
But the ML performance is, the accuracy of the model and so on, is a data scientist purview.
Is a data scientist purview.
Yeah.
So there's no wonder that data scientists are paid more than ML engineers, but one should just not confuse data scientist as the one who's data analyst at the same time, right? Because data analyst is a part of the data scientist job. That is, you climb the ladder to be a data scientist by first being a data analyst. Is that correct?
Sort of, right? It's what you said is absolutely true, right? It is part of the job. Like I said, the initial part of it, which is the exploration of the data, right? That's really what a data analyst does. And that's what they are really experts in. Very often they are very close to the problem at hand. They are, subject matter experts in a particular domain, which is very important to the business. But they don't necessarily have the core modeling skill set, which is very crucial for a data scientist.
Okay.
Let's say with even an undergrad degree, you're able to kind of be a data analyst, business analyst, synonyms. But you typically do need, a master's just to learn the requisite machine learning theory and so on to be able to do data scientist level work, building the models which actually are able to improve. Let's say this is about measurement of the problem, this is about improving upon the experience.
Right? So a data scientist is a master's level job role.
Yes, typically.
With a lot of deep understanding of building models.
Yes,
right?
exactly.
So when we say our AWS has a bedrock model, it's built by a data scientist.
Yes,
yes. It's built by a data scientist, right? So when Meta builds a new model or Google comes up with a new model, it's the data scientist brainchild that has kind of come to production.
Yes. Especially the very productized ones like Bedrock or Gemini and so on. Typically there's teams of data scientists who own the model itself, and then there'll be like a team of engineers ML engineers who actually work on making sure you're getting it in like 10 milliseconds, 100 milliseconds, that sort of thing, And they're very different problems. And for the success of a project, both sides need to cooperate very well.
Absolutely. You can't have one.
You can't have one without the other. People think that just because data science is the modeling part, it's the more cool part, it's the more difficult part, but that's actually not true at all. I do feel like many people have the perception that if you build the ML model, you're doing the most important part, which is, I really feel, not true, because it's a different skill itself and a very difficult skill to be able to take something which works on your laptop and make it work for 1 million people. It requires thinking through a lot more difficult challenges, like what happens in edge cases, what happens in this case, will I scale, it's a very different technical skill set, and equally valuable in my opinion. I wouldn't say that data scientists are paid more or anything like that. I would say they're equally valuable. They're their own career ladders.
Got it. Yeah. But ML engineers, again, for our young engineers and for those who have been on the software development side of cycle, they can start with being an ML engineer, maybe observe the data scientist, because data scientist is not only you need to kind of observe, but you also need to actually learn the theory behind it as well. So there's a certification, there's more master's level degree achievements and so forth in order to become data. Again, those who are productizing those models, like we said, scaling up, something that is seen on the computer to being used by millions, billions, is, I'm very sure, very senior level data scientist working on those. Or do you think that's also a myth?
Let me see if I understood the question. The question is to take something from your laptop and make it into
those people who work on scaling a model on a large scale, are they very, very experienced data scientists, or?
This would be an ML engineer, right?
Okay.
But I would say that the growth in these levels, which is, we've not really talked much about that right now, right? Like, what does it mean to be more senior in this level?
Yes.
Right? In a ML engineer, it's very similar to having senior software engineers, where you're kind of given a sort of high level product. You know, like something I've worked on a lot is with a chatbots. You know, we've like recently launched chatbots on Amazon India and US as well. So architecting the system, kind of understanding how the components play with each other and building that out at the tech level is what like a principal ML engineer would do, senior principal, right?
Yeah.
But a senior data scientist would typically work on very ambiguous problems. And the ambiguity and the difficulty of the problem would be, let me give an example.
Let's talk what ambiguity and what complexity means here.
Let's say that, let's take the example of house prices. Like you know, Zillow launched this model where they have a model to price houses.
Correct.
Like based on various aspects of the house, like how many bedrooms, how many floors, all that sort of stuff. Right? Now, maybe, this is not probably just one model, it's probably like a bunch of models, right? Maybe the team which wanted to launch this, or the product team who wanted to launch this, they said that, okay, you know, we need something which kind of gives us an estimated price of the product, of the house. And over here, a senior data scientist would kind of work with them to kind of figure out what do they really want. When you say estimated price, do you want like an estimated range? Do you want a single number? How precise do you want it to be? How often do you want it to fluctuate? Do you want it to be like a weekly updating estimate? Do you want like an hourly updating estimate?
Got it.
These sort of things is what. So the problem itself, while it seems simple on its face, it has a lot of nuances, ambiguities, which are needed to be sort of eked out from the product team by a senior data scientist.
Got
and like from that, they'll kind of come up with a rough plan. Okay, this is what we should try. And from that, they'll come up with what we call an experimental plan.
Correct.
I mean, like in data science, one of the main differences in a day-to-day between data scientist and ML engineer is that in data science, you don't necessarily know whether what you're going to do is going to be throwaway work. Because you'll try an experiment and it may work, it may give like a positive result, but also may not.
Correct.
Right? Whereas in ML engineering, you by and large know, okay, if I plug these things together, it should work. If it's not working, then I'll have to dive a little bit more, and then it'll eventually work. Right? But data science, it's really possible that you start out with something and it really just may not work. And then very often you have to pivot. You have to pivot to a different
a completely different technique.
A different technique, a different style of a different approach to the entire problem. So that's actually why the speed at which you try out things is really important. You know, at Amazon we have this whole bias for action.
Bias for action and fail fast.
Yes, exactly. Fail fast at just the modeling level. Just try one thing, then if it doesn't work, try another thing. Don't sit
on it, and
don't necessarily sit on it. And then because the idea is that eventually after some number of tries, maybe like it could be as much as like 10 tries also, something will actually work, and then maybe you're able to make it a little bit better, refine it a little bit, and then it becomes something you can hand off to a team who can make it a big thing.
Right. So it's rightly said, it's a scientist role. Scientists fail more than they pass. But when they pass, they make a huge difference to the general community or the application or whatever they are trying to do.
Exactly.
That puts the things into perspective. That why is the role of a scientist in there? Right. So a data scientist or an ML engineer, Abhishek, I feel is the one who should be able to play around with TBs of data, play around and make sense out of it, analyze it, but also at the same time never lose sight of what the big picture in terms of what is the application that you're looking at the end, right? And whether that application really needs an outcome which is a prediction from an ML model or from the data analysis that you have done.
Right.
So it should be more of application and user backward as compared to just kind of, engineering or keep building something which actually does not have a value at the end. So that is one skill that, even as a software developer or an engineer, one should have in the ML space, because it's not for everything. It's for something where it's highly valuable, it's for something where it is marginally valuable, and for some it is not valuable at all. Mainly I think even industries, whether an engineer, a software engineer want to embark on a journey of being an ML engineer or a data scientist, could first look at whether that industry would even need that.
Exactly.
It's not necessarily everyone and every industry would need that, right? Maybe that role is just because they feel that there is a lot of data that they want to manage. That's not a role of a data scientist or a ML engineer. It may be somebody who is able to just manage data, generally, just manage data.
You touched on actually a really important point, which is why in a lot of the job roles, as you said, particularly for data scientists, the job roles seem to be all over the place.
Absolutely.
And that's, I think, because a lot of industries, as you said, a lot of companies don't know exactly what they want to do with data. They've heard ML is a thing. Like other companies doing it.
Maybe they want to data mine. Maybe they just want to extract data from different sources. Maybe they want to have their marketing strategies built on what, but that is all traditional practice. You don't work without data, right? But data scientist or ML engineering is a totally different aspect. And that's what we want to tell our engineers, that you are a software engineer. Please take up a field of being an ML engineer. Your ladder to data scientist is very lucrative, but at the same time very, very satisfying, because you're doing something for millions of users out there. So it is very satisfying, but understand yourself. Only because you can play with a lot of data does not mean that you can become a data scientist or an ML engineer. You may as well be into data mining or something like that, or data analysis for that matter. You as a data scientist should be ready to fail more. Scientist is a word that is rightly applied. You as an ML engineer should be able to tune the models rightly in order to see the performances. And most importantly, your end sight of what is being used for, why is it being used for. Like, you need to have a product management mindset as well at the same time.
Right? I feel because many product managers are not, like, many product managers have come in software companies, have come from a background of how to think about software products only, right? I mean, they know, okay, like if I build this feature, it'll do this. But that's because the feature is very deterministic. When suddenly you have features which are ML features, which have scope of failure or doesn't work exactly as expected, it requires a totally different mindset. And I feel in many cases, product managers apply their existing mindset to these sort of problems. It's up to ML engineers, data scientists to inform that, no, this is something which may fail, call it out, before there's a big problem.
I completely agree with that. I think that deterministic nature of a product manager can, which is very feature-led, is not very, very applicable to the ML space and the data scientist space. No, that's why the two people working together and basically understanding what the requirement is, to a deeper level. I think that's where the start of it can happen. But there are a lot of resources, like Abhishek just mentioned. You need not kind of, be in a role or wait for an opportunity in your company to get the role of an ML engineer. There are a lot of resources which are also free. There's a community that is available for you with your similar mindset of people who can give you feedback, who can handhold you. We have mentors like Abhishek as well, who's taken that ladder, had this transition from being a software engineer to an applied scientist. So these kind of mentors are exactly the right place where one needs to start and see whether you fit into that role, and if you do, then sky is the limit to reach into it. But most importantly, whether you are in the right place or right time, and how to get into that right place is also what a mentor can handhold for you. So I'm very pleased we had this conversation, Abhishek. If we see young engineers showing interest in mentorship with you, I'm definitely going to forward them to you. And Reflections is going to do best to kind of also, if there is a larger audience who wants to learn more, then we can do more repeated series with them.
Absolutely.
Fantastic. Thank you, Abhishek, for coming.